Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on Building Energy Systems and Auditing in the module number 7. This lecture will be on Introduction to the Energy Retrofitting of Buildings. This is lecture number 34. So, in this lecture we will just going to see how different type of energy retrofitting of the building is done, what are the types and what are the key phases. So, as you know that we have seen just now that operational energy is the maximum energy that building is going to absorb. It has three phases that we have discussed in the module number 6, that it has a operational phase, it has before the operational phase, that is a embodied energy phase, and then there is a demolition phase. Demolition phase is very small. So, mostly it is the embodied energy in the construction time, and then thereafter the operational energy is going to take care of the whole life cycle energy of the building. But this particular life cycle stage, when the operational energy is going to be continued, there are some the elements may in the due course of time and because of some kind of the damage or some kind of the loss of life, it will actually absorb, due to that it will be absorb the more energy, building is absorbing more energy. It may be given as an example that low E coating glass can be fed down after 5 to 8 years or so. Maybe the coating which I have given as a temperature proof, or maybe the thermal insulation point of view in the roof, that maybe has its own life, maybe again 10 years or so. So, in between the span of the life of the building, which may be continue to 80 to 100, 120 years, sometimes we have to retrofit it, we have to do some kind of additional features has to be embedded into the building systems, or we have to repair it, we have to repair the systems, and as after 10 years you will have lot of other choices also, maybe from the material point of view, from the system point of view, which are the type of air conditioning systems or the lighting systems available today. We may get much more efficient systems after down the line of 10 years or so. So, why don't we embed that system? Then the amount of the operational energy required for a building will be drastically going to reduce. So, this particular the upgradation, and one is the regular maintenance, so that you have to do, we have to do always for a building, for any kind of the, maybe there is a water seepage, maybe there are some kind of a defect comes up in some of the part of the building, there may be a regular interval to whitewash the building, we have to do some kind of the color or painting in the outside also. So, those are the general requirement of the repair and the refurbishment, but from the energy retrofit is also can be done from the strength gaining point of view also. We are not going to discuss that one. Our discussion will be actually going to we will actually discuss the in and around from the energy savings point of view. So, here I have a flow diagram. So, there is a existing building in operation, we require some kind of the energy retrofit. So, that means we have to do some changes, we have to do some changes. We have to first see what are the type of retrofit, what are the measures we can take, we have to see some of the selection criteria, we need to know the budget of my client, that how much budget it is permitting to do so, and there are applicability. how that can be applicable in the building. Sometimes it may be under the budget, it may be under our wonderful selection criteria that this is going to be the best, but it may not be applicable. So, because there may be some functional issue, there may be some issue that the function of the building has to be disrupted because of that particular the additional thing that if I have to suppose a rooftop is used for some purpose in the sense it may be a dining purpose, or it may be kind of a rooftop. The rooftop is mostly maybe for the some kind of the restaurant is there, rooftop restaurant or so. We may not go for those kind of that the solar PV cells or whatever may be implanted there. So, the application is also very much important. The what type of sometimes it may actually, what I mean to say is that it may do some kind of a conflict with the application and the suggestive changes along with the functionality of the building. Anyway, so let us suppose we retrofit it, some retrofit it, some way we retrofit the building, energy retrofit, and then building will be again in operation. Building will be again in operation, but there will be slight changes. What are the slight changes? There will be some operating in energy before retrofit. So, I have mentioned that OE, BR. OE is the operational energy, BR is the before retrofit, some amount of energy in kilowatt hour or so. And after the retrofit, it has again it will consume some amount of energy, operational energy after retrofit. So, E energy, OE is the operational energy, AR is the after retrofit. So, now we have to see these two must be two different value, and definitely this the after retrofit value should be less with compared to the before retrofit. That is why less, because that is why I am actually doing something. I mean, I am going to retrofit the systems or retrofit the element. To do that, this thing retrofit, there may be some options. There may be 2-3 options available with me. I can take any one of the options. I may have some strategies. This is a spelling mistake. I will rectify that one. There may be some kind of a strategies. So, this is a spelling mistake, typological error. So, some strategies, there can be some kind of, we can do some kind of energy analysis, we can do some kind of the carbon emission analysis. For that, I can also do some kind of economical feasibility analysis. So, by virtue of that, I can select some strategy or some kind of the operations or the options for which has been given for the retrofit or so. Now, let us see what are the type of retrofit which is available with us. So, building energy retrofit measures, there are typically 3 broad areas. The first one is the energy conservation. There are some method which can be adapted to retrofit the building by some changes in the physical, I may say the items or the members of the building. The physical items may be roof, may be wall, may be window, may be some door, or some the envelope area, or maybe internal some areas which I can actually think of. I will change it and I will do some the small or large rectifications, and that will lead to less amount of energy consumption. So, that is energy conservation point number 1. And second, I may also do some kind of the physical change in the energy systems. Energy systems are, we have discussed in the second module. That is, I will change the operating type of the type of the air conditioner, which may be VRF kind of a system. Now, I can go with some kind of other kind of system, which will be constant air volume kind of a system. CAV system, I may go to VAV system, volume, the variable volume type of a system. So, those I can take some kind of a change. Even the lighting systems, I can go some kind of a change. Instead of the fluorescent lamp, I can go for some kind of energy efficient lighting system like LEDs or so. I can also think of some kind of a change in my escalators, my elevators, my other water pump, and etc. etc. So, those are also require some kind of energy. So, why don't I going to change maybe a booster pump which is actually pumping the water from the ground level to the top level. After down the line of 10 years, where I may get much more efficient type of the pump systems or the pump or so. So that is the type 1 way of this retrofitting. Second, I can actually generate energy. So I can actually go for some kind of a renewable energy. So if you remember in the last 3 lectures when we are discussing about the EPI calculation, EPI is actually footprint of the operational energy. In that footprint, we will only take care of the non-RE type of energy, non-renewable energy type of energy. Non-renewable type of energy. So if I generate some kind of renewable energy through solar, maybe from wind or from a biomass or something like that, my purchase requirement of the energy from the grid or maybe some fossil fuel will be less. So my EPI value will be less, and I will upgrade myself from maybe from 2 to 3 star or from 3 to 4 star or something like that. So that is another way to go for the retrofitting measures. So I can think of some kind of energy generation. So conservation, directly touch the building. Second, without touching the building, I just generate the RE type of electricity that will reduce my requirement. Third one is the energy management. What is energy management? I will not do any changes in the physical things. I will not going to change any, I will not going to harvest any the RE energy, but I changes some kind of the schedule, the management schedule. I'll go for some kind of a rules, some strategies in my office, in the hotels or in my airports or anywhere. I mean, kind of the areas where the buildings require a lot of energy, and that will kind to regulate the human the occupancy, that will going to regulate some kind of the energy expenditure. So that can be the way we can do something like we can use some kind of the electronic the sensor also. By virtue of that, we can regulate. We can actually regulate the shift. We can regulate some kind of the occupancy criteria also, and also the demand based kind of the how much is the demand, I will just supply that part. So that kind of the demand based generation or the conservation kind of policies I can take. So these 3 ways we can do. So we will discuss one after another. The first one is the energy conservation. The energy conservation is of 2 types. One is called the passive method, where I can go with the insulation, I can insulate the wall, I can insulate the roofs, I can go with some kind of a the double glazing in the windows, I can stop the air leakage from the windows and the door. I can go for some kind of the ventilation, we can optimize the ventilation, because sometimes the natural ventilation and the mechanical ventilation may mix together and create a kind of a conflict area. So I can see how much optimize I can do, because sometimes I require some kind of a fresh air also. So those are the areas, or those are the points if I can actually take, then I can say this is the passive method of energy conservation. There are some active method of energy conservation also, where I actually I have to touch the equipment. So I go with I will remove the existing equipment and go install for some kind of the energy efficient instrument, the equipment for generating HVAC and the light. I can go some kind of a solar shading. So I can go for some kind of a shading devices also, that can be act as active ways of cutting down my energy requirement also. So here again some other way around, we can actually think of some kind of a building facade to touch with, where I can go for some kind of insulation. Just I have told you, I can go for some high thermal mass wall. I can increase the thermal mass of the wall, that will delay my delay the propagation of the heat. We can go with some kind of a cool roof systems. We will discuss the cool roof system in the next lecture, which can change the type of window. We can implement shading devices in the window. We can use the fan forced ventilation for the cooling instead of the air conditioned areas. If suppose that particular area allow you to be the way we can think of maybe a series of the ceiling fans and the fan forced ventilation. So definitely if you compare with the fan forced ventilation and the HVAC systems, definitely fan forced the ventilation will require less amount of energy, and sometimes we can actually induct some potential amount of the natural ventilation for the cooling also. Whereas in the active mode we have the HVAC systems, we can think of some kind of a change in the type of air conditioner. Day by day we are getting very good and very efficient type of air conditioning systems in the market. There are a lot of competition between the different companies. So after certain years, if I want to see that whether this particular old system is not functioning well, we can directly go for the new type of system. We can go for the use for the active dehumidification systems. We discussed already in the other part of our lecture. Fan efficiency can be changed, and the efficiency of the compressor. So for those the equipments and all which actually is a part and parcel of the HVAC systems, each and every equipment we can think. Fan, why it will change? Because fan efficiency, if it is changed, the draft velocity will be reduced down, and if the draft velocity is reduced down, the cooling will be affected. So from that point of view, we can think of changing only maybe the fan efficiency. We have to see the cooling and heating temperature set point, that can be made some kind of the sensor kind of a thing. We can do for some kind of two-stage evaporative cooling also. We have discussed already that one in the earlier chapter. The energy generation point of view, it is very direct. We can go with the solar electricity, we can use the wind electricity, we can use the bioelectricity. We will discuss in the next module. The last module we will be actually see how to generate those kind of the RE in a building. The last one is the energy management. In the energy management, there are, you can think of some kind of a internal load distribution. We can think of and we can optimize the reschedule such a way that we can actually have a control on the occupant density. We can change the lighting fixtures, lighting power density also that way can be changed. The electrical equipment power density also can be changed because of the changing of the old equipment to a new and efficient equipment. Outdoor airflow, that I have told you, the mixing of the outdoor air and the indoor air can be think of some kind of a change, because you require always a fresh air entry, but how much that has to be that has to be optimized to reduce down the energy requirement. We can also check on the infiltration rate. So these are the internal loads are there, and there can be changes in the schedules and operation types. So that also we can think of. The HVAC operation schedule, if possible, we can change it. Then it will be of a regular kind of a scenario. We can be a peak demand can be reduced down, and maybe we can go for a overall efficient kind of the systems or so, or the energy use or so. Lighting schedule, similarly we can change. Electrical equipment schedule also we can change. So all the system schedule we can think of changing also. We can install the sensor based system, that is very much essential nowadays, because we are wasting lot of energy because of due to our some kind of the old habits, or which we should not actually perform very well. So from that point of view, we can actually based on the sensor systems, if you can apply in a building, it will be much good. The plug load control systems is also like the sensor based system, because through the plugs, through the points, the electricity actually channelized in the every look and corner of the building as per the requirement. So it can actually sense, and then actually requirement wise it can be fluctuate, and then it can control the plug load. So those sensor based systems and the internal load schedules operations are come under the energy management systems. So what are the key phases of this the building energy? So we'll go very quickly. We have a first phase of the pre-retrofit survey. So we have to do some kind of a initial survey to talk to the client, what is their need. We have to see some kind of the project targets we have to made as per the client requirement. We have to see, we have to actually work out some kind of the audit planning and some assessment. The next is the performance assessment. So, you have to actually do. So, it is again the part of the energy audit which actually look into the retrofitting system. So, we have to see the performance evaluation and some indicators, maybe the EPI can be indicated, maybe the how much is the LPD is the indicator, how much is the tonnage of refrigeration per square meter, or maybe the volume is the indicator. So, those indicators you have to look into, you have to do some kind of a audit data analysis and some performance assessment. The third phase what we will do is that we have to retrofit options can generate. So, we can see what are the saving potentials of energy, what is the saving potentials of the economic point of view, what is the analysis gives me, and what sometimes gives some kind of a risk. Sometimes we can actually prioritize the energy retrofit options or so. That is the third phase number 3. The phase number 4 is the site. Now, you have to implement these 3 phases. 1, 2 and 3 is the actually in the office or maybe the audit and all those. Now, as per the phase 3, the options best options can be implemented in the site, and we do some kind of a testing and the commissioning. The last one is the validation. So, whatever we thought in the phase number 3, that should be actually we should get in the phase number 5, that we should validate that post occupancy survey is required, the post implementation verification of the energy consumption is also required, and if it is not so, to do some kind of a little bit of change adjustment or so. So, that is the different key phases of this thing, the energy retrofit. Now, in this technologies what we see, again if you look into in a different perspective, what we see is that we had a demand side management. In the demand side management, there are 2 different sectors. One is the heating, cooling and the demand reduction. So, we can actually reduce the demand by virtue of this, the cooling roof, building fabric changes, tightening the window, changes the U value of the windows and all those kind of things, the insulations and all. So, that will give you actually some reduction in the heating, cooling demand, and we can also think of all the air tightening and the change of a reduction of the room volume. The other side, the energy efficient equipment we can use, that already we have discussed. So, those natural ventilation we can propagate, or we can upgrade the lighting things, we can actually see the system upgradations also. So, those are the demand side, and the other side it is the supply side management. So, in the supply side we can do another 2 type of management. One is the human factor and the energy users pattern. So, those are the occupant comfort, we can change the set point temperature, or we can see the sensor based kind of a scenario. We can do some kind of a regular management and the maintenance, occupancy schedules and all, access control, those we have already discussed. And other one is this renewable and the electronic technologies we can actually use, that we can use some kind of the renewable energy in this building and also the electronic sensor or so. So, we have a small problem over here. So, what we will see that the economic analysis. So, suppose the office space of 15 meter by 22 meter need to be illuminated, and the illumination level is required to be of 300 lux level. We assume that utilization factor 0.7 and the maintenance factor of 0.5, and we have 2 options with us. One, we can go with some kind of the fluorescent lamp, and second one we can go with the LED lamp. So, we have to find out the number of lamp required for these 2 options. LPD of the space, LPD is the lighting power density of the space, and also we need to see the payback period of how much is the payback period or so. So, the fluorescent lamp which is available with us is 60 watt, having efficiency of 40 lumen per watt, which is called as the efficacy, and the cost of each lamp is suppose 125 rupees, and whether the LED lamp is 28 watt, little less, but the efficiency is 90 lumen per watt. So, definitely it is much more efficient, much more lumen it is producing per watt, and cost is also very high. I mean, with compared to the fluorescent, maybe it is 600 rupees. So, please, one thing I must tell you over here, this cost and all these things are taken by me. It is not exactly that cost, it may be little bit more or so, but you have to see the essence of this particular problem, how to solve it, right. So, we have to find out the LED payback period of the LED and this two, and then we have to also see instead of the LED, if it is fluorescent lamp, then it is what is the two options you have to justify. So, in that we have to see that the office is running 8 hours per 8 hours with this electrical lighting, and the electrical cost of the electricity is 5 rupees per unit. So, one thing is that if you feel like there is a little bit issue with the how to calculate this particular lamp light or so, we have already discussed in the lighting system in the module number 2. I think it is the lecture number 1 or maybe the 3, whatever may be, please look into that. So, that lecture number 1 in the sense of the module number 2 lecture, first lecture or maybe the third lecture, where we have discussed about the how to calculate with this maintenance factor, utilization factor, lumen and all. So, please visit that one, and then it will be easy to understand. So, the general formula by the area method to find out the number of lamp is that N is equal to E into A divided by I, UF and MF, where the E is the average illuminance, that is 300 lux. That is my requirement, 300 lux is required to run that office or whatever. The N, capital is the number of lamp you require. The I is the lumen input. So, lumen input is different based on your wattage and all, and the efficacy. UF and MF are the utilization factor and the maintenance factor, already given 0.7 and 0.8, and capital A is the area of the room, which is mentioned 15 meter by 22 meter as dimension. So, it is almost 330 square meter is the area of the room. So, in that we will first go with the fluorescent lamp. It has a 60 watt is the wattage of the lamp, and the efficacy is 40 lumen per watt. That means 40 into 60 will be the lumen output. So, lumen output is wattage multiplied by this efficacy. The wattage is your watt, how much watt, and this is the lumen per watt. Okay, so you will get a total lumen value. So, in this case my lumen output will be 60 watt into 40. So, this is the lumen output, which is given as I, and this is your UF and MF, and this is UF, this is maintenance factor, this is your lux level, and this is your meter square of the area, right. So, based on that I got 74 fluorescent lamp has to be placed, otherwise you won't get 300 lux. Okay. So, that is the number 1. Number 2 is that, so if I place 74 and each will have 60 wattage, so I have to actually go for 74 into 60, that means 4440 watt. That much wattage, that means that much joule per second, that much watt power is required to illuminate that particular room, which is having 330 meters square of the room, to get a lux level of how much? 300. So, the LPD, light power density or lighting power density, will be electrical power required, that is 4440 divided by the area. So, that means 13.45 watt per meter square is the LPD of that particular room. Now, if I install fluorescent lamp is my one of the solution, case 1. So, how much the energy required per day? Per day how much I required energy, because I will run this 4440 watt for 8 hours. So, this much 35.52 kilowatt hour is the energy requirement. And cost of installation is how much? Cost of installation is 74 number of lamp I have to install with 125 rupees per lamp. So, it is 9250 rupees is the cost of installation. So, this is for my fluorescent lamp. So, what I got 74 lamps are required to illuminate. To run a particular day with 74 fluorescent lamp, I require 35.52 kilowatt hour as the energy per day, and the cost of installation for 74 fluorescent lamp is almost like 9,250 rupees. Now, let us see the next case of the LED. LED is having the lumen output, that is the efficacy is 90 lumen per watt. 1 watt gives you 90 lumen, whereas the earlier case 1 watt gives you 40 lumen. So, that is why LED is much more energy efficient, and I am going to use 28 wattage of each lamp. So, 90 into 28 is my total lumen output I. Utilization factor and the maintenance factor remain same. The lighting level, light level, the illumination level 300 lux remain same, and the 330 is the area remains same. So, I got 71 such LED bulbs or lamps required, and this 70 will actually require 70 into 28. Why 28? Each LED lamp is having 28 watt of the rating. So, 1988 watt is required, which was earlier case it was 4440, here it is 1988, almost half. Now, this particular LPD, if I want to calculate this 1988 watt is distributed, overall area is by 330 meter square to give you the required illumination level of 300 lux. So, the LPD is 6.03. Please remember last case it was 13.45. So, definitely the LED LPD is less. That does not mean that the illumination level is less. Both cases the illumination level is same 300. This 6.02 watt per meter square LPD, it is less because the LED lamp is much more energy efficient. It is having a higher amount of efficacy, 90 lumen per watt it has discharge, whereas the fluorescent lamp has 40 lumen per watt or so. Now, let us see the cost point of view. We required the energy saving, the energy required per day is almost about 1988 multiplied by 8 hours. So, almost about 15.908, which was earlier, it was 35, now it is 15, much less kilowatt hour per day. But installation cost for 71 such lamp is per lamp is 600 rupees. So, it is 42,600 rupees, whereas in this case in this case of the fluorescent is only 9,259,000 and it is 42,000. So, definitely the initial cost of installation of the LED is much higher. So, from that point of view to see that what should be my criteria. So, I have written down the both the cases. So, for the LED, the LPD are higher in case of the fluorescent, but the installation cost is lower in case of the fluorescent. The energy saving is energy requirement is higher in case of the fluorescent. So, now we can see that the excess capital investment, if I want to go for the LED, I have to pay 33,350 rupees more, because anyway I have to pay 9,000 rupees, 9,250 rupees for the fluorescent, but in case of the LED I have to pay for 42,600 rupees. So, I have to pay 33,350 rupees more in case of the LED. But in case of the LED, I can going to save per day almost like 19.616 kilowatt hour, because the difference between the fluorescent lamp requirement and the LED is 35.52 and 15.9 respectively. So, difference between them is 19.616 kilowatt hour is the my savings per day of energy savings, which is good, and cost of electricity is 5 rupees. So, per day I can save almost about 98 rupees of electricity from my bill if I go with the LED. So, I can actually see the payback period. So, I have paying 33,350 more in the initially, but each and every day I am going to get a benefit of 98 rupees. So, almost almost 1 year, 341 days I required. Of course, if you take some holidays also, it is more than 1 year. So, 341 days is the payback period. So, within 341 active operating days, my money, which is extra money, will be, I get it from the energy savings or so. So, this is the way we can do the analysis of the economic analysis, and these are the some of the retrofitted cases. I recently visited Western Sydney University campus, Australia. So, they have wonderfully done some kind of a shading devices in their library building, in their institutional buildings. So, I have taken some pictures, and that is all for today's lecture. So, we have mostly seen 3 types of energy retrofitting in today's lecture, which based on some kind of applicability and reduce down the annual energy consumptions. So, energy retrofitted solutions to be judged based on the payback period. So, that is all for today. Thank you very much.